Hey, good morning, everybody. I know it's kind of early for some of us, but my name's Jason Moulder. I'm with a company called Pratum. We're here local up in the Ankeny area. We kind of do cybersecurity on a lot of different facets as far as pen testing, audit, pretty much anything when it comes to security. So today we're going to be talking about AI and kind of the dangers that goes along with it. If everybody kind of knows what AI is, there's a lot of different things when it comes to it, when it comes to a scientific aspect. So we're going to kind of delve into how AI works and kind of what I foresee as some of the dangers coming in the later years. So some of this stuff is going to be more conceptual based. Some of it's going to be based off of some proof that we've seen over the past few years. And kind of go into a lot of different questions. Some people may kind of come off as, hey, this is more conspiracy theory based, and I'm definitely not a conspiracy theorist. I do find some of the stuff kind of fascinating, funny, or whatever, but I'm not saying that some of this stuff is going to happen, but it's a possibility. So trying to keep an open mind when it comes to that. And then we'll kind of go into a lot of different things of how, today we could exploit some of those things and they could be a reality. So like I said, artificial intelligence is an area of computer science that emphasizes creation of intelligent machines that work and react like humans. The whole point of it is to make decisions, do whatever that action is, and try to replicate the human aspect of it. When it comes to emotions, when it comes to visual aspects, physically moving things around, all kinds of different things. So any aspect when it comes to the five senses, any of that stuff, that's what we're trying to emulate in AI. So like I said, some of these are speech recognition, learning on itself, whether it's supervised, unsupervised. Some governments and stuff like that use it for planning, zoning type stuff, problem solving just in general, perception, that comes to like image manipulation, trying to decipher, hey, is this image what I think it is? So the computer takes all this and puts it into a digital form and says, okay, this is what I think it is. Then the ability to manipulate and move objects. So think about like your big factories like over in China where they got stuff that kind of goes up, picks up pallets and says, okay, I'm going to move this over to here without running into each other. So there's two main types of AI. You got type 1 and type 2 at a kind of like a high level. And then those are broken into a couple different categories. You got weak and narrow AI, which is like your very, very basic type AI. It's focused for one specific task. In this case, like if we design a game and we put every variable into it to say, hey, if I take all these moves and this is the outcome of the program to say, hey, I want to beat the human, that's where it takes all those different actions. It comes up with the best attack method, and it says, okay, this is what I'm going to do in order to win the game. The next one goes into a strong AI, which is where machines can kind of think and act just like humans. This is still kind of a conceptual aspect of it. We haven't really mastered a lot of this. We've mastered some aspects of it, but not as a human, because we can't replicate the emotion. We can't replicate whenever there comes to stress and other environmental factors that come into different things. So that part of it, it's, we as humans, we're kind of unpredictable when it comes to that stuff. A machine can say, okay, we can do, this or that, but if you throw something in at last second, I might not, I don't know how to react to that. So type 2 is kind of based off of the functionality of whatever that task is. So we got reactive machines that are kind of go back into that basic aspect of it. They have one specific purpose, and they don't have any information that you feed into it from any past event. So whatever information that you're feeding into it currently, then it makes a decision off of that, and nothing from it had from before. So IBM created a program that beat Gary Kasparov, which is a chess player, and it was called Deep Blue, and it was kind of one of the first POCs when it came to AI. That was back in the 90s. Limited memory is kind of going into, you got, like certain small data sets that are kind of broad. You feed that into there, they can use certain actions that they know are 100% every time this is the outcome, this is what happened. And they can kind of base decisions off that. I mean, a lot of us have that in our phones, and with predictive speech, we got Siri, Alexa. They can say, okay, yeah, we're going to order, new, detergent or whatever the case may be, or say, hey, don't forget you got a something coming up today, that kind of stuff. And that could be, based off of you walk by it, there's a peripheral, or a proximity sensor for your device in your home or whatever, and it says, hey, don't forget to go pick up the kids or something like that. So it's predicting those actions based off of patterns and stuff like that. So next one comes into theory of mind, which is, it's kind of complicated on this, and we've kind of seen several examples where it's been really not a great outcome for certain things, if anybody has followed this in the past few years. But so it's machines' ability to try to understand humans and try to replicate that aspect of it, not necessarily understand it, but what they believe is human emotion. So they're trying to do that and understand how the human mind works. Some examples were Microsoft's Tay chatbot. So if anybody remembers that a couple of years ago, it was not a very good thing that happened. It kind of went out, picked up on different people's comments and stuff, which I think we had a lot of different types of trolls and stuff out there feeding different information into it. And Microsoft kind of freaked out because it became anti-Semitic and all kinds of stuff by itself. So not really a good thing when it comes to the public aspect and your reputation as a company. Facebook, they developed one. They don't like to call it chatbot, but it's a chatbot. I don't really care what they say on that, but basically they had two different bots out there, and they started communicating, and based off of how humans interact with each other, we use slang, we use all this different stuff. They decided, hey, we're going to create our own language and start communicating that way. So they kind of took on their mind of their own and started going rogue on that. So then we got self-awareness, which is more of a true human aspect. So that's being sentient as far as every aspect possible of being a human, from the emotional to, hey, I can pretty much do anything on my own. I don't need any kind of input from a human programmer or anything like that. I can adapt to my environment. I can do whatever I want. And this is kind of really a controversial thing when it comes to industry as a whole, just because we see a lot of things in movies, we see a lot of stuff like that where you look back at like Terminator, Skynet, that kind of stuff. It's science fiction in an aspect of it, but it's also could be a reality one day. We see that with certain projects when it comes to government weapon systems and stuff like that. We got drones that can go out. They can pick their target from hundreds of miles away. Say, hey, this is the building I'm targeting, and drop its payload or whatever. So what does all this stuff look like from kind of a 20-mile stare or whatever? From a visual aspect, you got these different categories like I was talking about. You got machine learning, you got natural learning process or natural language process, vision, autonomous vehicles and robots. And those cover a lot of different things. There's a lot of different terms when it comes to AI in the industry standard. You got the machine learning, which is kind of where machines try to do things on their own. You feed it a lot of these different data sets, they can be a lot of different things when it comes to, okay, this is a specific data set that only applies to penguins or whatever, whatever the case may be, right? So they want to try to understand every single aspect of it, and the machine goes over these algorithms, and it basically kind of looks like a staircase. You know, it'll start at the top, go through each one of its parameters, narrow down its results, go back through the cycle until it comes down to however many iterations it is. And that kind of stuff can be supervised, unsupervised. Supervised is probably the most cautious and logical method when it comes to this, but there is the ability to let it do its thing on its own. Natural language processing, that's kind of what the chatbots we were talking about just a minute ago. It's trying to figure out, okay, what are you trying to say to me? Everybody's got, different types of dialect. They got, I got kind of a southern drawl because I'm from Houston, but, everybody's got a little bit different accents and stuff like that when it comes to how they talk. So machines got to try to figure out, obviously somebody from like Brooklyn that's like, I want some water, instead of water, it's like, hey, we got to kind of figure out how do I interpret that and make that the same exact digital sequence every time. So that's kind of how that stuff works. It's complicated on the back end, but it's just kind of like whenever you're going to, your Google searches and stuff like that, whenever you start typing in a question or whatever, it's trying to autofill a lot of that stuff for you to say, okay, based on certain actions that you've done in the past, you're probably looking for whatever. But a lot of times we see that it gives you kind of a random thing that really makes no sense to what you're actually looking for. So it's still a work in progress, but it's going. Then text generation is, everybody uses that on their phone, I think. Then we got some other things like vision, and that goes to a lot of different aspects as far as actual digital images to images that are picked up from traffic cameras or stuff out on the street for picking up, people's faces and stuff like that. All that stuff's got to be turned into a digital signal that the machine understands. It's all, ones and zeros in the end ultimately. So how it does that, it's kind of complicated, and we really don't have time to go into the details of that stuff. But a machine can take those actual physical photographs, scans, live camera shots, stuff like that, and it can interpret that stuff and say, okay, this is 100%, even though I have my face turned like this, I have it up like this, whatever the case may be, it can take that and replicate that into the same sequence so it can identify you. It takes a lot of math and stuff like that to go into it, but it happens. When it goes into robots, like I was saying, one of the examples was a lot of factories, bigger factories overseas, stuff like in your bigger warehouses, stuff like that. They have a lot of these robots that use a bunch of different sensors. They use cameras as well to identify each other to say, hey, I got proximity sensors as well as cameras to say, this is an object, I don't want to run into it. And we've kind of used that over the years to go into autonomous vehicles, which is a little bit different because now we got to identify actual risk factors, and that comes into people. Yes.
Oh, I didn't mean to interrupt. Oh. I noticed on your chart you have machine learning as part of artificial intelligence, and I know in the industry today those terms are almost used interchangeably. How do you distinguish?
Machine learning is really specific to more of a analytic side. So it's not necessarily, AI is kind of the whole science behind it. Machine learning is saying, hey, I want my machine to kind of analyze specific data and interpret that into whatever my defined algorithm is for that. Whether it's through saying, hey, I want to solve a math problem, or I want to make an efficiency of, how my water flows through, pipes or whatever throughout the city, stuff like that, or to say, based on my growth, of my city. This is how, I plan on for urban development and stuff like that. So it's they're almost the same, but they're a little bit different. Yeah, there is.
Most of the time we hear AI now, I mean, granted, there are some where it really truly is AI, but most of the time we're hearing it, it really is machine learning. They just, AI sounds cooler.
Yeah, yeah. So artificial intelligence is the overall of all these things combined. So that's just kind of the blanket for it. When it comes to machine learning, we're specifically only looking at the machine doing specific tasks. If we're looking at those lower level types of learning, but you can also have, like it shows in here, deep learning. Deep learning is going to be for like very, very specific tasks when it comes to like genetic coding and stuff like that, where you got thousands and thousands of different, data points that you're trying to analyze all at once. Us as humans, we can't do that in a realistic fashion. It's going to take years and years, but if we feed that into a machine can kind of go through that and keep, plugging away day by day, depending upon how much computing power you have for that device. So a lot of these you're looking at, petabytes, of just storage or, RAM and stuff like that in order to compute a lot of this stuff. And, you got big things like your big vendors out there, like Amazon and Google and stuff like that. They're doing a lot of stuff with our data, unfortunately, so all the stuff that you're getting feedback from your phones, all these APIs that feed into these things, it's creating data sets for them to say, okay, here's how I'm going to improve my product to you. Here's how I'm going to improve my experience to you as a client. That's what they say anyways, but, we know otherwise. All right, so what does all this mean as far as for us when it comes into technology and stuff like that? For us, AI is in every aspect of our lives every day, whether we know it or not. Like I was saying, when it comes to going to websites, they use some sort of AI to try to get you, ads to you and targeted information to say, hey, these are things that I think you're going to like. So videos and stuff in social media, it's going to be like, hey, check out this or whatever, to say, hey, these are things that are good for you, even though it may not be. But it's meant to make life easier, more efficient. We have home automation now. You got, Alexa, Google, all that stuff in your house. Everybody's got some sort of something, to say, hey, turn on the lights, whatever. So we got all this stuff all around us. And then a lot of times, cities are using this to, get meter readings and stuff like that. So they don't have to physically walk up in your yard anymore. They can just stand out the road, scan your stuff and everything like that. And then we're also getting into, the autonomous vehicles is starting to become a big issue now. And people are worried about, okay, what does that mean for me? Am I going to get run over? Stuff like that. And then, they've been pretty successful for the most part as far as those go. But when we get a little bit further in here, we're going to talk about how manipulation of those images from this camera and stuff like that can interfere with how those data sets are interpreted, by the computer and stuff like that. So there's been countless times since, this has been really, it's been a concept since computers were started as far as AI. If we look back at, some of them, just movies and other articles and stuff like that throughout the years, AI has been kind of one of those things where, we've all been like, okay, that'd be cool if we can create, and robots that can do all this stuff for us or whatever. And as we progress through the years, we're getting kind of lazy as far as some of that stuff goes. So it wouldn't be a surprise where we see a lot of this stuff happening more and more, especially with drone deliveries and stuff like that. You got Domino's that has a vehicle that can come up and deliver your pizza. You just go out, type a code on the door, opens up, stuff like that. And a lot of that stuff is still kind of in test phase in bigger cities and stuff, but it's coming as the days go on. So in the example over here, you get a query for what's good and evil. This kind of shows how the machine's trying to determine, what is good and evil. But if we don't define that to them, and that's still kind of a hard thing to define as a human characteristic, what I may consider good and what you may consider good is two different things, so at the same time, we got to take all the possible variables in there and say, okay, all these things could be good, all these things could be bad. And the back end, that's where the machine learning portion of it comes in, is how it determines what is actually good and bad. And it's kind of based off of a higher percentage in one category versus the other. So, and if it doesn't know, it kind of just sits there and is waiting for the next data point. So, yes.
In that previous slide you just had, at the beginning of this talk, you talked about the thing was strong AI, and you were talking about two algorithms. One where it would learn from a data set, and another one where it just kind of learned by itself.
Yes.
I'm looking at this and saying, well, this is kind of an example of where it doesn't have a data set to learn from.
Exactly.
What is it using?
Like I said, So the question is, we were talking about earlier in there, we got strong AI and weak AI, and the overall how it determines how to make a determination off of a known data set and an unknown data set. So in this case right here, we're kind of using that where it doesn't have a pre-existing data set. So it's kind of like whenever you first start up a log server, right? You don't have anything in there to begin with. And then once you connect your sensors and everything like that, your collectors, it starts putting your data in there. So at that point, it can go in and whatever software you have at the next layer can take all that data and interpret that. And that's where an AI model exists within applications. And we're going to get in that here in just a few minutes on how you can exploit that factor of it to take those either known or unknown data sets to possibly weaponize that into, if that kind of makes any sense to you. Yeah, it's very complicated. We're doing it at a very high level, because we can really get into some really crazy talks with this stuff. So we all, most of us in here are somewhat into cybersecurity. Is that a pretty accurate statement? If not, we probably have some people that are just getting into it, people that have been into it for quite a few years. If you do just a quick Google search on cybersecurity products, most of us use these things every day. Whether it's your organization uses it to determine, threat activity, malware detection, threat intelligence, stuff like that. So we can use it in a lot of different things, and these are common vendor names that you see out there. And I think everybody has at least one product or a similar product like this in their environment somewhere. So, and then if you're looking a little bit further down, there's certain things where it comes to, like I was just talking about, log analytics and stuff like that, where we're trying to correlate a lot of information into certain aspects. And if you're looking at just from a collection standpoint, you got logs that are being fed in raw format into your environment, into some sort of database in there, right? And in years past, you'd have to kind of manually create rules, or you'd have certain rule sets that would say, okay, I'm going to trigger my events and my alerts off of these particular rule sets, right? So the AI aspect of it is taking that to the next level. So it's taking those individual things, but it's trying to combine all the other aspects of it to make a decision for you, and say, hey, I'd like to see all machines, with admin, somebody that logged in with admin or whatever. I want to see that in real time. So it's going to try to correlate all that stuff as quickly as it can for you. So here's an interesting thing that happened here in the past year or two. So Sean Carter and Chris Olah, they're creators of this program called Deep Dream, right? And one of these guys, they work for the bigger side of Google and stuff like that. One's kind of an independent guy. And basically, they take photos from a network called ImageNet, right? So it's this huge, huge database that can take images and feed them into just a huge database, no matter what it is. And it tries to say, okay, every single thing in here that is a dog, these are all categorized as dog. No matter what is actually all in the image, it tries to take all that stuff. Well, they tried to take all this stuff and reverse engineer it and create a new image from it. So if you had 10,000 images that said dog and, all the different parts of it, they would take all those images and combine it into one and try to make something like we see here on the screen. But as you can see, you got a lot of weird stuff that's going on in the image. The face of this guy, the hands and stuff like that. It doesn't quite know how to make out different defined like lines and stuff like that. The background, you can kind of see some different columns and stuff like that. And that's based off of averages that it's trying to determine, okay, 99% of the time I see a particular line and a particular design with these colors and stuff like that. And 99% of the time it's this. So I'm going to fill in this area with this data that I believe is a cloud, but in reality, if you look in the front of a horse's head, you can kind of see there's more column shapes in there rather than actual clouds. For the most part, you can kind of make out, yeah, it's a knight on a horse and it's being led by somebody else, but also in the bottom left, you can kind of see some modern images that really make no sense to the whole thing at all. I mean, besides the dog head as the saddle and stuff like that, but yeah, that was kind of their project to kind of say, okay, we can take images, we can basically take all those values and recreate something else from it. And that's kind of where we are trying to use that in the cybersecurity aspect of it, and then we got to look at it from an attacker standpoint. Can they do the same thing? And that's really where the scary part comes into it, because they could ultimately go, can I corrupt this data? Can I put it into a format that can attack these systems that are meant to, interpret this data? Like this gentleman's question here, they didn't have a defined set to begin with. Can they take that new set? Hold on. All right. Can they take that undefined set and add new data to it? And in this case, that's what they're doing. They didn't have anything to begin with. They just analyzed all these images and tried to create something from scratch. So that's kind of how we're going into that part of it. All right. So here's a strong example what they also did with a lot of these images. And it's kind of hard to see, but if you look on the left side over there and the right side, you got similar images of gray whales and great white sharks. From a distance, they look almost the same. And in the top right corner, you got the rows of teeth, the one that circled baseball up there. So what it decided was, hey, every time I see this row of teeth at this certain angle, I think it's the threads of a baseball. So instead of it saying, hey, it's a great white shark, it's going to be a baseball now. So even though we as humans can interpret, no, that's a great white shark's teeth, but the computer says, no, it looks too much like a baseball. So what they did is they went down there, they took the two same exact images of a gray whale fin right there, and they took a postage stamp sized image of a baseball and they injected it into the picture. And you can see right there, there's drastic result difference, between the two. So 91% you got great white or gray whale, and then with that image injected in there, you got now a 66% chance of a great white shark, which we know that it's not true. So this is where it starts getting kind of curious and kind of scary to me. Is, hey, we got enough people out there that have nothing but time on their hands to go in and just upload stuff to all these public domains that are out there. All your pastebins, your whatever, they can just spin up a domain today and just throw thousands of pictures that make no sense to anybody. And if you got software that's out there, scouring the internet, creating these data sets from nothing, and interpreting those internally, to your vendors and stuff like that. If you think about it from a malware side, if we got code out there, we got predefined things, for our AV vendors and stuff like that to say, okay, we know that 99% of this code is what we have, but we don't know what to do with this last little bit. If we're ingesting small portions of it from multiple resources, how can we not take that little bit and recompile it inside and launch an attack? So think about it that way. If we're going to take little tiny bits that don't make any sense, but they're still stored internally on your device or through the vendor, and we use that to manipulate the AI model that's built inside to interpret that, it could take all that data together and compile an exploit internally. So, and that's kind of how that goes into it. So, I don't know if any of you guys here went to DEF CON back in 2018, but IBM, they came up with a POC for AI malware. So it's a very targeted, very, very specific type of POC for this, and it was called Deep Locker. If you guys read about it or not, basically what it does is there's a couple different layers into the attack. So it kind of goes into, what are we trying to attack, who are we trying to attack, and when. So there's a couple different things that are all layered within that, and that happens in an embedded AI model of, in their case, they use a common software tool, which we'll go into in the next slide. And so because it's very specific, the conditions that they were doing in there, it creates a unique key each time that you want to do it. And since you kind of control the data, you can change that key on the fly. So if you say, hey, instead of targeting this gentleman here, I want to target you. So since we're in here recording or whatever, it could be in here capturing a bunch of images of everybody's faces and creating new data sets to compare. So if you take that data that's in those data sets now, it can say, okay, now I want to target this individual instead of you. So, and if that's launched to common software throughout the world, say a million different PCs, when you walk by that PC and the camera picks up on you, it's going to target right there. It doesn't matter where you're at in the world. So it gets kind of crazy as far as that goes. And it's almost impossible to reverse engineer because you don't know what the variables are and what the intended attack was for that individual, And it doesn't have to be individuals. It can be geo-IP locations. If you just bring your computer into proximity of something, if you say, hey, if you get by the traffic light cam out here on whatever road this is, I'm not super familiar with the area, but if you get out there and say, okay, if I get within 10 meters of this particular sensor, then it's going to launch my attack, and it could be, hey, I'm going to stay on your computer until 10 years from now or whatever, and then I'm going to migrate somewhere else. And going back to the different types of AI and the actual sentient aspect of it, for me, it's like we're wanting to, weaponize this stuff, for certain things, but at the same time, you got where us as humans, we have the, flight and fight type responses and stuff like that. So if we want to survive in our environment, we try to do everything we can, So imagine a piece of malware that's super sophisticated that can propagate back out, because it's like, hey, I'm going to do this, but I also have some sort of segue out to the rest of the world. I need to propagate my code back out because if I'm killed here, I can't continue what I'm supposed to do. So think about it in that aspect of it and how it can be kind of scary, and get kind of complicated later on down the line. And kind of what I was getting into just a few minutes ago of the different layers that goes into it. You got the what what aspect of it, which is can be kind of simple and can be kind of complicated, from a typical standpoint of threat actors nowadays. They have some sort of motivation, whether it's money, whether it's, just embarrassment or just to be a pain, and say, hey, we're going to shut down your operations, cause you inconvenience. It still costs money to clients and stuff like that, even if that happens. But you also have, the who is actually do this. If we get into stuff like the supply chain, we had a kind of a incident like that not too long ago where a lot of hardware devices were compromised by China through a small little tiny microchip, less than the size of a grain of rice. So if you're looking at that, they can, launch specific malware targets and stuff like that into that. But imagine that on an AI level, going faster than we can ever compute, and stuff like that. So if you're able to get through those two layers and then you get down to the actual malicious intent of your payload that's in there, that's where it gets really, really hard to reverse engineer it. Because typical payloads, you got, your payload, then you got some encryption, entropy, and stuff like that when it comes to how those particular aspects work. And usually it's like, hey, we got one hard-coded key for like, ransomware or something like that. And we just got to figure out what the algorithm is and crack that, And then you got one aspect that's controlling all that. In the case of AI, it's like, no, we don't really care about that. We can change that on the fly whenever. And then my CNC at the end can say, okay, now I can take that new data and recompile what I'm going to do. So, and that's kind of what they did in that case. They took WannaCry, they embedded it into a conferencing software. That software, the scenario was, hey, we use a lot of these things like, any conferencing software, that's out there. So we use a lot of stuff, say Skype, for instance, we use Skype all throughout business and everything like that. Imagine if we had a hidden payload in there and how many businesses we could affect. We could say, okay, we're going to target this company today. We're going to go to this target tomorrow and everything like that. And we can keep getting different ways to compromise these companies. And it doesn't always just go into how, particular aspects of it work. They can say, okay, certain users that operate at this level, we can just target that, or we can, there's a lot of different variables, like I was saying, when it comes to geo IP locations, data, facial recognition and stuff like that are going back through the AI model and feeding new data to your CNC. So all those things can get very complicated and stuff like that. If you look at these slides here, we got some government contractor out there that actually building robots, that can kind of do some of these identification and stuff like that and attack a target based off of these AI models, right? So in this case, more likely they have it configured to say, all right, we're going to see a paper target that has the black silhouette. It's got the rings on the inside. That's going to be my target. Well, we know that computers and machines, they communicate via various different type of methods. Whether that's light, whether that's sound, whether that's radio frequency, network communication, stuff like that. We've seen it with drones in the past where, hey, we can jam a drone, we can bring it down. Iran did that to one of ours a few years back. It can happen, And in this case, hey, who's to say that we don't corrupt your data and now we can target individuals, or we can target a group of individuals, with your weapon that you created here. So it's kind of like Terminator, in that aspect of it, because it can be a reality. It's just we're still kind of in that infant phase as far as how things are going and whatever. But like I was saying, if we got different sites like GitHub, Pastebin, ExploitDB, a lot of our security devices are out there collecting these malware samples. They're collecting threat intelligence from tons of different sources. Those vendors are consuming that, creating their own proprietary information and stuff like that. But that data is still residing somewhere, whether it's inside their own servers or out on the public internet. Once it's consumed in there, if we get enough of little bits and pieces, if we got a corrupt AI model on the inside, it can put all that stuff back together. And now we got a very targeted, very nasty type of situation when it comes to malware and stuff. So, like I was saying, with home drones and delivery and stuff like that, imagine a situation where we got, corrupt data that we're sending, whether we're broadcasting over FM, AM, or other types of RF frequencies and stuff like that. And those drones kind of fly in our area. We know that we can intercept drones pretty easy. We also know that we can manipulate car data as far as autonomous vehicles and stuff like that goes. So with all those different things that are going out there, and we get those to act like humans and have that human emotion aspect of it, things could get really kind of crazy when it comes to AI. And imagine, hey, these are meant to be a drone delivery service. What if we hijack 1,000 of them? We send them off to do another task, or somebody hooks up weapons or something to them. You could have a mass casualty type thing, on a very autonomous scale, when it comes to how that thing's being attacked or where it even comes from, and without the ability to reverse engineer where that attack came from. Hey, it could be anywhere in the world. It could be anybody. And in reality, it's not even a person. It's a machine doing it, And if the machine has its ability to react and do things on its own, ultimately it's not us doing it. We're looking at, a factor where we're fighting warfare when it comes machine to machine. So it gets kind of crazy and complicated when it goes into that. So, one of the greatest guys, if you guys watch the alien stuff on History Channel. But like I said, I'm not a conspiracy theorist when it comes to that. But at the same time, it kind of opens your eyes and makes you think about, hey, these things can be a reality, And we got a lot of creative people in this industry that, hey, if I can do it, I'm going to do it, And that's kind of where some things in my aspect of work and stuff like that, it's like, if I want to break something and just say, hey, can I do it? Yeah, that's kind of what I do, So, and I think that over the years we may see a lot of stuff that when it comes to this that could get pretty nasty, and it may start more onto the state actors and stuff like that in the beginning, but as data is becoming cheaper and cheaper, being able to throw stuff up into the cloud and everything like that, build big cloud server farms and stuff like that, from an individual standpoint, computing power is now at the touch of a finger, and if you're skimming credit cards and stuff like that, it's not your money, to create these things. You can do whatever. You got a lot of these organizations, like Russia and stuff like that, that are funneling billions of dollars a year. They're not just like I'm just a skid out there doing whatever, throwing out some random exploits. They're getting paid big money by their government or other governments to do malicious things, So, and a lot of times these things go unnoticed for years, Yes.
So I have a question. Can you talk about the IP addresses, the types, and like 4 versus 6, and how that
As far as when it, just as a general,
yeah, just in general, because like I've been affected by cyber
okay.
for the last 7 months, and what I've discovered is that there is, and it's a long story. I've started tracking the IP addresses
Hmm.
to see how it moves as I leave the house, I'm in the public, or I sign any open network.
Okay.
And I've noticed, some things that make sense that don't make sense, but I don't know what that means because I'm not in IT, I'm in finance.
Okay. So her question is kind of a high level of how, IPv4 and IPv6, work as a general thing, and how you can determine where, the originating packet comes from and where it goes. This kind of goes into more of a networking aspect of it, but at a high level, you got, traffic from each individual node that's out there, and it gets assigned an IP address. If you're using, version 4 or version 6, it's just an identifier on that network to say you are who you are, right?
Uses V6 versus, because I would go to a regular person's like MediaCom connection, I would only see IP4, and IP6 was kind of tacky.
So the way those two protocols is because of, as networks grow, they only have X amount of IPs that are available. So IPv6 is now a longer chain, a longer identifier. So you now have 10 times more than you did before, with IPv4. But I mean, it's a little bit more than that. But for your sake here, it's just, we're going through and they're identifying those things. Both protocols are still working regardless. It's like, hey, do I prefer this one over the other one? So with the IPv6, it's just because there's more and more things that come into that, and it allows more connections into your network. So it's not really saying, hey, we're limited to a specific protocol when it comes to that, but it allows more connections into the network. So as we grow, we're just going to run out of IPv4 is basically what's going to happen. So we're going to have to go to a bigger protocol that can handle more computers onto this network. So, and network isn't just, from you to your home router or whatever. It goes from you to your home to your ISP to, the government backbone and stuff like that when it comes to these big trunks of data coming and connecting the rest of the world together. So when it comes to how you're trying to figure out where these IPs are coming from, there's, different indicators based on location and stuff like that you can kind of trace back. Each device that it talks to can be tracked back, whether it's through, firewalls, switches, routers, stuff like that. And as you go through, they kind of make a chain through each thing. But if you're using other types of things like proxies and stuff like that, it's going in, telling it it's one thing, but in reality, it's talking to another machine, and it's hiding where your actually original stuff is coming from. So,
But it used to be that,
Can I ask a question too?
yes. Over.
With your talk, I know you talked about some of the different security vendors talking about different AI. They use AI in their software. Do you get a feeling that they are actively aware of these potential threats and kind of working to?
It's one of those things of the human aspect. Ignorance is bliss, when it comes to stuff. Currently, most vendors are looking at what can I provide to our clients? What are they looking for? What functionality? Comes to doing pen testing, a lot of times you see websites that just want, bells and whistles and things to work. They don't really care about the security when it comes to it. They'll deal with that later, because if they make enough money and they get something, that comes back in the end, whether it's some sort of repercussion, they get enough money to cover it, or, hey, we'll play catch up. We know it's kind of on our, long-term goals or whatever, but yeah, they know there is some risk, but they may not know exactly what it is at this time.
How are ethics being handled with things like autonomous driving and who crashes into who and might maybe taking what?
So, yeah, so that's kind of a good question. When it comes to, we got to have insurance and stuff for our cars right now because we're physically driving it. Insurance companies right now don't know what to do as far as, who to put the blame on at that point, because it's not a human making the mistake. It's that vehicle. But then it comes back to, who do you put the blame on in the end? Are you, because you're the owner of the vehicle, do you accept responsibility? they haven't figured that out yet. So it's still a lot of things. It's like, hey, if my machine decides it wants to go out and, form decision on its own and do something that I didn't tell it to do, is it my responsibility or is it whoever coded it in the beginning? So it gets complicated. There's no defined answer for that right now.
I think the ethics question is really interesting because, I heard it phrased in the way of, okay, this autonomous vehicle's driving and it knows it has 4 passengers in the vehicle. There's another vehicle coming straight for it, unknown number of passengers. Does it go head on with the other vehicle or does it swerve and take out that pedestrian that's walking by on a sidewalk? How is the vehicle going to figure that out? What is the ethics behind it? Whose life is more valuable? Is it the 4 people in the car? Is it the pedestrian? Is it the unknown number of people in the other car?
And and think about it from
They're not laws or ethics, so it's like you just deal with it.
and think about it from a medical standpoint. What is the viability of life? When it comes to the survivability rate, when it comes to if something were to happen. Unfortunately, sometimes it's like, okay, elderly and children are probably less likely to survive in, something like that, where it's a situation where, the viability is probably lower for, those two groups rather than, a middle-aged person, So how do we make that decision? We, as people, still face difficulties when it comes to that. But a computer is just going to go off of statistics. Whatever it feels is the most likely choice at that point.
Will may boil down to just numbers. Oh, there's 4 people in my vehicle. I'm going to just go for it.
And going back to the image of the whale and shark, once it decides, that this is a shark or this is a whale, that's what it's going to go off of. So yes.
So we often say that the humans are the weakest link in the security chain.
Yeah.
So we're training computers to think like humans now. Are we going to have our computers attest to security awareness training and everything?
Exactly. And that's kind of where I was thinking about it too. It's
We
like,
detect this from like a propaganda thing where we're just injecting all this code. And is there anybody actually working on it?
yes, a lot of the bigger organizations are working on this, and like I said, when they've launched some of this stuff out as kind of a POC, with their chatbots or whatever, they ended up finding out sometimes that it looks good in the lab and everything like that, but once we put it back in the real world, all of a sudden the human aspect of it comes into it and it becomes very negative, So I got about 2 more minutes, so a couple more questions. I'll get her back here and then I'll get you.
Question about machine learning and deep learning.
Yeah.
One thing that we're in the predictor for the projector product
Mhm.
is being able to figure out what actually triggered off the alert. So in your experience, does AI, I know it uses a lot of data, are you able to go back and see what led to that final conclusion?
Yeah, and that's what we currently have in a lot of our products, where we have the human aspect to go back and review it and dispute those things. And when we dispute those things, we change that AI model in there. Whenever we say, no, this is a false positive, now we're feeding new data into that AI model to say, next time, don't make this decision based off of what we feel. But if you got multiple analysts that are going in there making their own interpretations of it, that's where things can get complicated as well.
Concerning the good and evil AI, would that be getting cultural? Like you would look into a community's culture and creating the morals based on those social norms?
It could be. We don't have enough to definitely say that, that's what the aspect is, but it could be a possibility where different regions have different perspectives, and that could change how things are handled as far as the good and evil. One more question.
Going back to the teaching AI to be like humans,
Mhm.
do you think we would have to have a lifetime of human input, of 60 years of human input? Are you really interested in that?
I really don't know at this point. It's really limitless at this point, as far as what we can do with it, and that's why we haven't achieved that level of sentient, maturity when it comes to certain AI stuff. We can do a lot of it, but we don't even know how our own bodies work. You know, we don't know how the brain works as far as how it makes these decisions and stuff like that. So until we can understand that as humans, how can we replicate it into machines? You know, so. All right. Well, that's all I got for today. I thank you guys. If you got any other questions, I'll be hanging around here and we can meet up after this and stuff. So thank you guys for coming.